Hello, I'm James, and with my teammate Dennis, we're going to be doing a study on manufacturing of an artifact called the peristaltic pump. So, what is the peristaltic pump used for? It is used in situations where you don't want a liquid inside of a tube to be contaminated, but you're trying to transport it or displace it to a different area and in certain quantities. Um, the pumps are used in a variety of fields, which lead to consistent demand in the market and have a number of industrial uses as well as medical uses. The pump allows specific dosages to be separated, which can be helpful for things when you need to separate it into different containers or specific medical dosages for patients and things like that. So, how does it work? The peristaltic pump works through the compression and relaxation of an extremely flexible tube by a rotating rotor with rollers attached to it. The tube is commonly made with silicone or rubber. This is because the materials are extremely malleable and are not easy to break when the rollers are doing its job. As the rotor rotates, the rollers compress certain areas of the tube. A vacuum is created which propels the fluid forward, and each time a fixed volume is pushed through. This results in a precise fluid separation, which has many applications. What components are involved? So, in this machine, it's relatively simple. You have a rotor with a roller attached, a mechanism which loads the tube, and a control system, especially in peristaltic pumps in medical fields. They usually have a button interface which allows you to select how much liquid you want to let through and how fast. These components have very few material requirements. Essentially, the only material requirement is the tubing. The material, as I said before, needs to be rigid enough to hold shape but not break, and flexible enough as to cut off the flow when the rollers pass through it. To meet these requirements, the most apt choice would be silicone tubing. In other than that, the casing can be used with this can be made with a simple plastic, and to be extra reinforced, a steel frame could work to ensure no breakages over time. And the rollers would also be steel and would be made with via metal shaping methods. The primary fabrication technologies used would be just metal casting to create the rollers and essentially just assembling a number of components together. Casing would also be used via metal casting or sheet metal cutting, and the assembly would be relatively simple. It would involve screws and those sort of things, and that's about it.
Peristaltic pumps are commonly used in industries that require high cleanliness, such as food processing and pharmaceuticals, since all that the fluid touches is the tubing of the pump. The lifespan of the pump can range from 200 hours all the way to 1,000 hours, but the key factors in ensuring this include the quality of the parts and the pump's composition, the conditions in which the pump operates in, and the maintenance of the pumps also are included, which include the replacements of parts such as the tubing. To allow for the creation of a close as possible to our ideal pump, the inner diameter of the tube and the outer diameter of the pump head should be relatively larger as compared to the other members of the pump to allow for the best flow rate of the pump. They are also created with tighter tolerances to ensure for the proper flow functioning and to reduce the likelihood of there being leaks, which in turn improves the lifespan of the pump. The workflow firstly begins with the sourcing of the raw materials which are going to be used in the pump, and once done, a quality check is done on the materials, which prepares it for the machining and fabrication process, creating all the parts of the pump. After all of that, the assembly process begins, and once done, the pumps are ready to undergo the testing required and then be packaged and shipped. The materials that get used for the pump have to be compatible with the fluids that would be used in the food and medical industry, so they aren't toxic and they're recyclable. Due to the materials being recyclable, in the manufacturing process, when there's excess scrap materials left over, they can be recycled and then potentially used once again in the creation of more pumps. The costs involved with the manufacturing of the pump include the sourcing and transportation of the raw materials needed, the labor, which involves both manual human labor as well as the use of machines, and the testing of the quality and functioning of the pumps. Creating these pumps in the industry could have a pricing range from being in the hundreds of dollars to the thousands of dollars.